Alright, it's time for the scariest video of all time, okay? We are gonna try the USACO 2020 December goal. God dang it. There's like a 25% chance I regret this because it was literally one of the hardest goals ever, dude. The cutoff was like 600. It's crazy. Hello everybody, I'm Kara, and today we are gonna be trying out the December contest gold, and I'm not sure if I'm gonna do all three in this video. We shall see. You'll probably know in the title, but let's just get into it, okay? The ill-fated result of watching too many do-it-yourself engineering videos on the web, Farmer John has accidentally released a self-replicating robot. Okay. The farm can be represented by an n by n grid. Okay, it's only to 1,000, but it's probably still hard. Where each grid cell is either empty or filled with rock. Alright. And all border squares are filled with rock. Okay. Some non-rock cells are designated as possible starting locations for the robot, and he initially places them at one of the possible starting locations, and every hour that follows, all copies move in one coordinated mass in the same direction, either north, south, east, or west. Okay. After D hours, every copy of the robot replicates. Okay. Oh, dang. Okay. And the original. Okay. And over time, they might come to occupy the same cell. Okay, so they shut down as soon as any of them move into a rock. Okay. And you want to help the cows find out the number of empty squares that could potentially at some point in time hold a robot. Alright. Seems complicated. So contains two space separated integers, okay. So I'm assuming you can't create a robot in rock because that would basically be crashing into a rock, right? And you got next n lines, okay. Why does every d hours matter? We're trying to find the number. Yeah, why does how often? Oh, I see. Okay, so if every hour it replicates, that means that it'll move once and then replicate and then move once and then replicate. Okay, so they're all gonna move at the exact same time, which means what? Huh. Wait, so what are the starting points? Like anywhere? These are considered starting points. Okay. Oh, that's so weird, dude. Okay. So I guess, what? Okay, so you can either start here, you go there, and then it replicates. Okay, this is complicated, bro. Okay, and the other option is this. So you could. What are the locations that could be occupied by robots mean? Oh, so just like no matter what, they could possibly hold a robot. Okay, let's think about it. So if we just put a guy here, right there, then we need to move him and then see what happens, and move those dudes and see what happens. So every single robot replicates. So if every single robot replicates, that basically means that your height is gonna get like +1 and your width is gonna get +1, right? And then it's just one blob, okay? So do you immediately die if you move into a rock? Or like, so if you go there and then you move down, it doesn't not count. So you immediately die if you get into a rock. It does not count as occupying it, okay? Well, we could do n squared technically, so if there's a way to do dp on it somehow, right? Like basically, to get to, there is a way to get to here and here and here, right? And then we could check if there's a way to get to there. How can we do that quickly though? Okay, well, it's easy to mark these guys as a distance 1, right, from the thing, and then if you have these guys, could happen on turn 2, right? Oh, wait, so we could do it based on the center guy, right? Okay, yeah, so we could do it based on the center. Okay, I think I have an idea. Let's see. So basically what I'm saying is if you have like a bunch of dots, right, then basically we could do BFS to figure out like this is 0, right? The first plot is 1, 1, 1. And then the reason why this cannot be a 2, right, is because like at time equals 2, okay, so at time equals 1, the robots look like this, right? At time t equals 2, they're gonna look like that, okay? Right? So essentially, if we went here, our robot would extend into this wall, it would extend way into that wall, it would extend this way and this way, right? So essentially that's not gonna work, so we can't put this guy at the 2. We could put this guy at the 2, because he is, wait, could we? No, because he would go into these two walls, so that's not a valid 2. So now we are done basically, right? So now we have the numbers on it. Now we just expand all the numbers, right? So 0 doesn't get expanded. This guy expands into these places, right? This 1 becomes into these places, and then this 1 expands into these places. And right, we got those answers, and then we do the same thing for the bottom. Okay. Now the one thing that's hard is like figuring out whether a thing is valid in this certain spot, right? Like you had to check, is this within 2 of any walls? So what's a fast way to do that? Because that could take like n squared time, theoretically. I mean, we could just go through all of the, I mean, we could BFS from each wall thing, right? And then that'll set the distance from walls. Okay, we have some idea, that's good, but we had to figure out how far away things are from wall. What's the nearest wall to any single point, right? Like, for example, for a 1, this guy is like 2 away from this guy because he had to go 1, 2, so that's why if the guy is 1, he doesn't interact with the wall here, right? So how do we keep track easily of which guys are how far away from each wall? Could BFS work? I mean, technically you only had to go through each one once, right? Because if you mark it as visited, then you're good. I mean, we could go through each one and see if they're adjacent to a wall, right? Okay, I think honestly BFS would be the fastest way, right? So you basically push all the dudes who are 1 distance from a wall, then you push all the dudes who are 2 distance from a wall, then you push all the dudes who are 3 distance. Okay, so let's just say theoretically we had the distance of each point to a wall, right? So then basically our strategy would be, let's try it on a different sample input. Let's try it on this guy, okay. So basically you have like this, you have like that, you have like that, you have like that, and you have like that, and you have like that. Okay, so he starts here, and essentially he only replicates every 2 hours, right? So this guy's going to be 0, 1, but then at 2 he's going to replicate, so he can't get over here, that's not going to work. Or actually, he replicates, so he goes 0, then he goes to 1. Yeah, he can't go here necessarily, right? Wait. No, he's allowed to go there because he hasn't replicated yet, so that's fine. So 0, 1, 2, 0, 1, 2, 0, 1, 2, then he replicates, and now, can he move up? No, he can't move up. So you could say, okay, at 2 he has like 2 over 2, his size is now 1, right? So he's like this, like that. And then you could say, you can't go down, you can't go up, so now only this is a 3, right? Then could you go up with a 3? So that would be, that would still be 1, so that would be like these 4 guys. So he can move up, so that would be 4, 4, okay? Or would 4, would that be fine? Okay, so 4 up here. Yeah, that would still be fine, but when you get to 4, after he moves to 4, then he becomes size 2, which is still fine technically. Okay, no, it's not. Then he would crash into a wall. So these guys cannot move. This guy cannot move. Okay, and the 3 can still move to the right. Right? Yeah, it can still move 1 to the right. Then it explodes. At which time you can't move anywhere else. So this is our numbers. Okay, so let us get it clean. 1, 2, 3, 4, 4, 4. Okay. And then we just expand it, right? So 2 would be size 1, so this guy and this guy is going to be taken. 4 has length 2 on either side, like that, and like that, like that. 4 has 2, okay? And then this guy has like that, like that, like that, and like that. Okay. That's nasty, but I think that is right? So it's like, go up 2, like that. Oh, yeah, this is touching the side, so it's like that. Okay, nice. That is what we got. Very good. Okay, so we basically have a strategy for this. Let's see if we could code it up, maybe. Oh, it's such a nasty imbol. Okay, well, I think we could do it. Let's do it. Wait, actually, that's kind of annoying, though. How do you keep track of whether you can move up or down? Because you have to check if each cow in your thing can move. So that might be too big. Wait, so 1000? Yeah, that's still n squared. I don't think you could do n cubed. Huh. Oh, I guess you could just check if the guy you're moving to. Oh, okay, yeah, that still works. Okay, we're good. Let us do some epic BFSing. I love BFS, bruh. I didn't know we were gonna do BFS in gold. That's pretty good. Replication. All right, let's do this using namespace std int n comma d. Then we will have our, let's see. Okay, so originally we just want to do BFS from the starting points. Well, I mean, that's not relevant. Let's just do, we'll have a vector int of starting points. I think we just do s, okay. And then we should also just have our grid. So grid boolean, we could say, and we can make it 1001 by 1001. Okay, so we are just going to do cn n d, and then for int I equals 0, I less than n, I plus plus, and then we have string, row is like that, and c in row. And we'll just go for int j equals 0, j less than n, j plus plus, and we'll set grid ij is equal to row j is equal to wall. We'll say if it's equal to a wall. Alright, So now we've read everything in. Oh, we should also probably check if we have row j is equal to s, then we want to, it will still be false, so I guess, yeah, I guess unrelated. So we'll just do s dot pushback j, or we should probably have parent int. Okay, pair, or why don't we do some type defing? Okay, or yeah, type def pair int pi. So we can make this pi, okay, and we could push back I comma j next. Okay, and then we'll just have like a visited array, which will store the distance from each of the starting points. So we'll do like, I don't know what, 1001, 1001. And then for each ij, we probably want to set visited ij to equal -1. Or do we want to do some mini stuff? No, we're doing BFS, so it should be fine. Okay, so visited is -1, and now let's do some BFS. Hashtag include Q. Bruh, I have not coded BFS in so long. Bruh. Q, pi, Q. And then we'll basically just go for pi, p, in start. We will push it to the Q. And we will also set visited of the thing to 0, I'm assuming. So visited p dot first, p dot second is equal to 0. Alright. Now, while not q dot empty, we will basically, what will we do? We'll set like car is equal to q dot front, and oops, that's not q dot front, pi car, and then we do q dot pop noise, and for, we'll just go through each of the options. So, I guess, okay, we'll do like a adjacency thing. So int adj x, should we do pair? Yeah, let's do pair. Okay, so pi adj of 4 is equal to 1 comma 0, 0 comma 1, -1 comma 0, and 1 comma 0. Okay, or 0 comma -1. There we go. So this is basically just a list of all the adjacency thingamajigs, and basically we could just loop through it, right? So we do for pair add, let's say I guess in adj. So that'll just make it go up, right, left, and down, and we'll basically say if not, okay, well, let's say int new x is equal to car dot first plus adj, or I dot first, and int new y is equal to car dot second plus I dot second. And if not visited, or I should not say new x and new m because it's m comma n, not xy. Alright, that makes more sense. Do not want to confuse myself. So new m, new n. Then we will just do visited new m, new n is equal to visited car dot first, car dot second, plus 1. Well, and we also want to make sure that it is not a wall either. If it's a wall, then we want to not. So we'll do if grid or not grid new m new n, and it's also not visited, then we do that and we put it in the queue. Alright, so now we just want to check if it works. Why don't we just loop through it and make sure we're not trolling. Very good. I with an n, I plus plus, very cool. See out visited ij. Oh wait, yeah, this is not a thing. If visited ij is and visited ij is less than 0, okay. Then we see out visited ij and then a space, and then we put an end out over there. Let us test this boy out. Okay, so all the walls are -1s, then yeah, you can see it worked, right? So there's a distance 1, 2, okay. Nice. So now we want to make sure that things are not a distance from stuff. So, okay. Well, okay, let's just get the distances from the walls working, and then I will explain my master plan. Wall dist. Alright. So, essentially we can literally just copy this, right? Except, instead of doing for this, right, we had to go through all the n squared one to check if they're walls. I mean, technically we could like store which ones are walls, but like honestly there's like half of them are walls, so you might as well just go through the whole thing. So for int j equals 0, j is less than n, j plus plus, if grid ij, then we want to set visited, but this time we're using wall dist, and we want to push it to the queue. Make this smaller. Okay. Oh, that's too small. Okay, hold up. And there we go. Alright, so this is good for our next one, and we do the exact same thing, except this time we don't need this, we just need and visited or wall dist is less than 0. So we should probably set wall dist to -1 over somewhere. Where do we do that? Here, okay. And instead of doing this, we just do wall dist. Oh yeah, okay, now we have to be kind of careful because the border is not walls, so we actually had to make sure that this is not negative. So if this, or if new m is greater or less than 0, or new m is greater than what? N, or greater than or equal to n, or same thing for new n, or that, then we do this. Okay. And then we do the, or is this right? I think this should be right, so why don't we try it? Wall dist. There is a 69% chance that I got an index out of bounds error, but we are not going to get trolled by that, right? That's kind of slow. Wait, hold up. No, there's no way that's that slow, right? Let's just see where it's getting stuck. Try like see out here. Oh, okay. So we need these all to be true, not ors. God dang it, what am I doing? Okay. And noise. Well, I did not mean to do that, but that did not work. Hold up. Oh, yeah, we want it to be greater. Okay, yeah. I just flipped my stuff. I technically could have done it using like the ors, but I should have put parentheses, but parentheses are lame, so we are gonna do this. Let's get rid of this. Okay, there we go. So now we have the wall distances to everything. That's good. Okay, that's very good. And now we could basically just do our algorithm. Okay, so essentially the strategy is, what is the strategy? Okay, so basically what we're going to do is we're just going to go through the array and set the ones that are not valid to -1, okay? So we'll just loop through the entire array for int I equals 0, you know the drill. Okay, so why don't we figure out the formula, right? So essentially we could, okay, so if this guy is 2, right? Okay, so this guy is a distance 2 from the nearest wall, right? So if the guy who here and the guy you're moving to both have distance 2 from a wall, wait, okay, so this guy's a 3, right, technically? Or how does, yeah, so this guy's a 3, so essentially because you'd have to move, wait, but technically you could do like from here to here and it'd be fine? No, it wouldn't be fine. Okay, okay, that's big brain, okay. So essentially, so this guy has a distance 1, right? But the guy who's coming to this guy is also a distance 1, so that's why this doesn't work. So essentially, if the guy you're coming from and yourself are both distance 1, then you are trolled. Well, let's say for example, it was like every day it changes, right? And this guy with a 1 and this guy with a 2, then it's fine. Or actually, sorry, if this guy with a 0 and this guy with a 1, then it's fine because this guy is not a 1, but this guy is a 1 in terms of size. So that is why that's fine. So, so size is just going to be your, like, your number divided by the d, right? So, yeah, okay. So first off, we need to make sure that it's not a, if it's not a wall, right? So we basically say if grid, or if visited, if not grid, let's just say, if not grid ij. And then we also want to make sure that the visited, okay, so, we need it to be less than that. Or we need one of the two to be less than that. Well, you need the one that you're coming from to be less than that. Okay, so basically we want if visited ij minus 1 over d, right, is greater than or equal to the wall dist ij, then we want to set it to -1, right, because then it's problematic, right? So we'll set visited ij is equal to -1. Alright, so now let's try printing out visited and see what happens. Okay, so you can see, right, we got the one that we want. So 0, 1, 1, 2, right, that's what we wanted, and then it will give us the right answer if we do the BFS on those guys. Okay, we're almost there. Let us just check if it works on the other one, just so we're not too trolling. Yeah, you can see, right, like it moves here, it can move either way there, which is also what we wanted on the other one. Okay, now this is kind of smart. We can basically just like represent each one by how many times they can replicate, right? So essentially, we had to set the replication amount to how far away they are to the nearest wall, right? So for example, if your guy is a distance 2 from a wall, then he can't replicate, right? Let's see. So you could go there. So he can replicate once. So this 2 guy can't replicate twice, but he can replicate once, which is not valid unless you are, well, yeah, he could replicate once. He could have been once, but okay, yeah. So yeah, this guy could replicate once. Okay. That's right, right? Okay. So essentially, we also want to set else we want to set visited ij is equal to min of like visited ij and the distance wall dist minus 1. Okay, let's try it. Let's see what that does. Okay, we're getting there. Okay, so yeah, this guy can only replicate once, this guy can only replicate once, these guys cannot replicate, otherwise they would die. Or no. Wait, really? Yeah, they can't replicate or they would die. Alright. Seems legit. And now we just replicate everybody, right? So, essentially, now it's gonna be like reverse replication or something. Yeah, it's gonna be like reverse replication. So what's the smartest way to do this? Okay, so basically the idea is you split up and then you set each of your kids to the max of that thing and another thing, and then you push your kids to what? Oh, do we have to use a priority queue or something, or could we just do it? So I'm trying to figure out how you could quickly determine from like these numbers, like get the replicated answer. I mean, we could easily use a priority queue, right? We could just do the highest ones first, or no, lowest. Wait, what? Highest? Highest ones first? Well, highest ones first seems inefficient though. Oh, wait, no, that's not gonna work. Oh, okay, yeah. So we could just do BFS on the guys who are marked as like 0 or 1. We could just go off those, and then we'll be good. Okay, so in this case, these guys are the guys who are good, so we want to add them to a vector of good dudes. So we'll have like vector into good, right? And we will just do like what? Good dot pushback. Oops, I want parent. Okay. Pi, nice. So we do good dot pushback pi. Or no, we want a good dot pushback ij. Okay. Or actually, we could just directly push it to the queue. So queue dot push. And essentially we had to do exactly the same thing, except just with a slightly different variation. So instead, is there any way that we would push somebody later after he's already been pushed a second time? I don't think so, right? Well, yeah, it'll never be like that. So, okay, so we'll have a case. So if wall dist is greater than 0 or greater than or equal to 0, then we want to set, well, yeah, okay, so if it's already set, then we want to just set it to the max of the current wall dist and the one we want to set it to. So wall dist ij. Wait, why am I doing, okay, visited. Okay, so if visited ij is equal to max of visited ij, comma, visited car dot first, car dot second, plus 1. Otherwise, we will push. Actually, so no matter what, we set that, but in some cases we will push. Okay. If visited is less than 0, and our visited current is greater than 0, visited num and num. And it should be visited car, hold up, num, and it should be -1 because we are like flooding out. Okay. Sorry I'm being incoherent, but this is actually kind of big brain. Okay, hold up. Okay, and then at the very end, we just find out how many dudes are 0. Well, you set yourself to 0 after you spread, so we'll do, so visited car dot first, car dot second is equal to 0. Okay, alright, let's try that. Hey, okay, so see, all the zeros are the ones that are good. Let's test if it works on the other one too. Okay, let's see. Oh, why did they not get set to zeros is the question, but I think, is that right? Oh, I think it's right, but actually, is it? No. Hold up, what? Okay, why don't we look at it before? Okay. That should be right. Is it right? I'm pretty sure it's right. So I just need to make sure the spreading is working. So this guy the 2, alright. That guy the 2. That guy the 2. Alright. Okay, maybe we should just print this out every single time this happens, just to see how it's spreading. Everybody should be zeros at the end of it. The negative ones are so annoying though. Maybe we don't even need this. Let's just try this. Oh, that's so annoying. Well, we want to push. Okay, so it's just not, I can't get the 2 to work. Let's see. Should we do a priority queue? If we do a priority queue, then it will do the top guys first. Yeah, I think we need a priority queue. Okay, so we'll do a priority queue, PQ, and we'll do priority queue. And we'll just do a pair of int, comma, that. And we'll do that. Okay, so now, instead of doing this, we will do pq.push. Okay, and instead of doing that, we will push with the visited ij. So basically the idea is it'll take the top guys first and then it'll put the next dudes up. So now we can do the same set thing and we can push with the distance. So now we can do visited car dot, wait, what? Visited, what did we have before? It was visited new m, new n, okay, you guys know what it was. Comma, visited car dot first, car dot second, -1. I think from PQ you could do pull, right? Could you pull? Forgot. Oh, it's just pop. Okay, and then we do. Okay, there we go. I think we finally got it. Let's test it again. Basically, the point of doing the bigger guys first is not. Oh wait, what? Now hold up. Higher priority, right? So the 2s get split into 1s first, right? And then they push all the other dudes. So these guys are all 1s. Okay. And then why are they not expanding the 1s? Let's see. Cout car dot second dot first space car dot second dot second endo. Okay. Right. I hate debugging. God dang it. This is so sad. Okay. So 3 6. So here. Whoops. 3 1 2 3 4 5 6. Okay, that's a 2. All right. So that gets split into 1s, then 3 5 3 4, and then 4 4. Oh, I see. Yeah, I just had to set it to that. We don't want to do max. Okay. That would make a lot more sense. Okay. And we want to do that if it is greater than 0. Okay. Hey, there you go. Finally, dude. It is finally beautiful. Holy, that is lovely. And now we can finally count the zeros and we are done. Holy, that took a while. Count, or well, count is equal to 0. And then we'll just go through it, and if visited ij is equal to 0, then we do top plus plus, and we see out top. Feels good. Please work, I beg. Hey, it works, holy moly. Let's go. Well, I mean, we'll see about that, but that is pretty good. Let's try it. Bro, why is the impl on this one so nasty, though? That's so sad. Okay, where are we? Oh, wait, what? No. Do we need longs? Wait, what? No. Right? Oh, bro, you can move back on yourself, dude. Wait. Bruh. That's troll. What? Oh, you can move back on yourself. Wait. Are there... What's the sample input for the next one? Let's see. Wait, what? Oh, shoot. This one doesn't even work. Okay, hold up. Okay, well, I guess this is a problem, too. I think the idea is if you die on your next move, then you can't move anymore. So you shouldn't push your next dude. So let's see. Do we have to do it during the... Okay, maybe we should just do, like, if your current thing is... If you die on your current one, then you should just not. Or if you're dead, then you shouldn't. Okay, let's just do that. If you're dead, if waldist, new m, new n... Or not here. Over here. Or actually, wait. Okay, why don't we do waldist first? Okay. Equal to your number. So if you're 4, and then you duplicate at here. So yeah, if it's greater than or equal to, or less than or equal to? Yeah, so if it's less than or equal to, then we want to break. So we'll do, if waldist is less than or equal to visited car, I guess here we should do it. And then we break. Or no, we continue. Okay. Or, well, there should be visited. We could do -1 over d. Alright. And then we don't need this thing after. Okay, let's see how that does. Okay, god dang, that was a lot of bugs. God dang it. Okay, I kind of changed it a little bit. It's basically the same idea, but I basically just stopped it from going past in the visited thing. Where is that? Yeah, so I just checked this condition over here instead of waiting to check it afterwards. So hopefully this works a little bit better. I think there's still something I'm missing, but hopefully this works. Let's see. Alright, a moment of truth. Let's see. I for sure won't get all the. Whoops. How did I get all the endels? Rip. Not bad. Okay, we did it. Let's do it. Epic. Let's go. Very nice. Finally. Bro, that took so long. Holy. Okay, yeah, just to be clear what I changed, like, I didn't change anything here, really. The main thing I changed was I went over here. I put the wall distance ahead, and then over here, I didn't continue doing the BFS if the wall distance was too small. Alright, that one was pretty hard. It took me like 1.5 hours, but I'm gonna end it there. So, cause I can't really record for that much longer, but I hope it was helpful. Thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know if you have any questions down in the comments, cause that was that was hard for me, so it took me a while to just process it and get all the debugging done. So if you had any questions on that, let me know down in the comments below. But other than that, thank you guys so much for watching, and see you guys next time.